So the first thing I would like to do is just cover the activity, take you to activity number 5. The first one is just the methods of initial rates. If you take a look at this, this question right here, you're given 3 chemicals and you're given the rate for 4 different experiments. Now, for those of you who were in my lecture, remember that what you want to do is pick 2 experiments in which 2 of the concentrations doesn't change. So you can see how the rate changes for only 1 chemical that in which the concentration is modified. So I'll give you an example. Let's say I want to figure out what the order is for the first chemical A. Here we have A as a reactant, B as a reactant, and C as a catalyst in this particular example. So if we want to know the order of A, and the rate's always going to be written as rate is equal to K times A to the X, B to the Y, and C to the Z. Okay, and your job is to determine X, Y, and Z, and K. So the way you figure out X, the order in A, is pick 2 experiments again, in which the concentrations of B and C doesn't change. So if we take, excuse me, the first and the third, you see that the concentration of B does not change. It's 0.15 in both, and the concentration of C does not change. It's 0.001 in both. So we select that. Now this rate change, 2.5 times n minus 4 and 2.5 times n minus 4, that is independent of B and C because those are constant. You can already see that the rate doesn't change. It's too easy. Rate doesn't change even though you double your A. Okay, so 2 to the what power equals 1. You guys can figure that out. Anyway, that's how you would approach that. And then you just answer these questions accordingly based on your work here. Okay, what are the reaction order for each reactant? A, B, and catalyst C. Show your work. Calculate the average rate constant. Once you figure out the order of A, B, and C, then you can pick any experiment. In fact, what you should really do is pick all experiments and calculate an average, calculate K for each. The temperature hasn't changed, and then take the average of that. What you should see generally is that the K does not change. Okay, you should prove that to yourself. So that's that. As long as you don't change the temperature, the K does not change. Write the complete rate law for the reaction, 30 degrees. Make sure you include K and the appropriate. Okay, so 30 degrees is the condition in which this reaction, these experiments are being run. Okay, so that's fine. That's not new. That's not new. And then what is their overall order, etc. So you guys can answer that. We've covered that in lecture. And for those of you who are not in my lecture, you should have covered that already in kinetics. This is a second problem. This one's a little bit more challenging. The caveat I would like you to remember to solve this problem is, again, for every 10-degree increase, the rate doubles. So we go from 25 to 35, and the rate's 25. At 25, then at 35, the rate's going to be 50. At 45, it'll be 100. At 55, it'll be 200. The rate doubles from its previous for every 10-degree increase. Okay. Now, this particular question says, okay, this is the reaction we're studying. Aluminum plus sodium hydroxide goes to aluminum hydroxide and sodium nitrate. And I ask you to make a simple assumption here that the rate is going to be equal to the rate equals K aluminum nitrate to the X power, sodium hydroxide to the Y power. And I tell you, assume that the reaction is not zero order in any chemical. So it's not aluminum nitrate to the 0 power. Otherwise, it wouldn't even be included in the rate. So assume it's not 0 power in either aluminum nitrate or sodium hydroxide. It's got to be 1 or greater. It's got to be 1 or greater. Okay. Also note that as a rule of thumb, the rate doubles for every 10-degree increase, and thoroughly explain and show what your by calculation the choice and your ranking. What you need to do is you need to rank A, B, C, and D based on which is the slowest, which is going to have the lowest rate, okay, based on the conditions that is written here, and which is going to be fastest. So you rank number 1 as the slowest and rank number 4 as the fastest. Now, it seems like it's overwhelming, but what you need to do is for any problem where you're comparing and contrasting, compare 2, pick the winner of that, and do your next comparison. Pick the winner of that and make your next comparison. You can't look at all 4 because there's too many variables involved. What you do is you look at 2 reactions and look at the variables that are different between the 2 and figure out which one's the faster between the 2. You take that one and you compare it to the next one and you see which one is faster. So eventually you'll get to the point where you figure out which is the fastest. And then you can do the same for the rest, which is the next fastest, which is the second fastest, and then which is the slowest. So you're always going to compare 2 reactions at a time, not all 4. It'll be too much work. Okay. Now, what I would also suggest is that you take a rate law that says rate is equal to K, is equal to K. Now, the K is going to change. Why? Because look at the temperature, they change. So if K is equal to 25, the K is going to influence the rate of the reaction. But let's say a K is equal to 50 at one temperature, let's say 10 degrees, okay? If the concentrations are the same, if the concentrations is the same and we double the temperature, I mean, we raise the temperature by 10 degrees, then that K is the responsible one that is going to double. That's the one that's going to be double if we don't change the temperature, if we don't change the concentration. Remember that temperature influences K by the Arrhenius equation. Okay. So think about that. If you forget, watch the rerun of this video. So here's the strategy that you want to use in this particular problem. Write a rate law. Rate is equal to K, concentration of aluminum nitrate to the first. Why the first? Because first is the lowest order. Anything higher just accelerates that rate. So you want to find the conditions in which the changes in the concentration doesn't influence the rate that much, but it still influences the rate. If you put 2, then yeah, it's going to influence the rate, but it's going to basically double it. Okay, so pick the lowest set of conditions that still influences the rate, and the lowest set of conditions is for first order kinetics. Remember, these things cannot be 0 order. So think about rate is equal to K, aluminum nitrate to the first, sodium hydroxide to the first. So use that as your rate law. Remember, the rate law does not change just because you change the temperature. The rate law does not change just because you change the concentration. The rate law is the rate law. So use that, and then use that rate law when you're looking at the first set of conditions. Let's say we look at aluminum A and B, aluminum nitrate in A and aluminum nitrate in B. If you take a look at this right here, you can see that just based on temperature, the temperature goes up twice 20 degrees. So the first 10 degrees, the rate will double. The second 10 degrees, the rate will double from that. So think about that. And then look at the concentrations. In the first condition, it's 0.1. But in the second condition, it's 0.01 and 0.1. So the concentration difference here is that in the second reaction, the concentration of aluminum nitrate actually drops not by 10, but by 100. but by 100. So in one instance, the temperature goes up by 20. So it doubles, and then it doubles from that. But the concentration change, look at the concentration change between the A and B. It doesn't decrease by half, because half of 0.5 would be, half of 0.1 would be 0.05. Okay. So it doesn't decrease by half. It actually decreases by 10. So that's what you need to look at when you're trying to figure out between two reactions, which one is faster, the first or the second. In the one hand, you're going to see concentration change. In the other hand, you're going to see temperature change. You got to weigh that too. And write out the rate law so you can see how the concentration actually changes that ratio between the two reactions. Figure out which one between the two is faster. Take that and compare it to the next one. Figure out which one is faster, take that and compare it to the next one. And that's basically how you would, again, it says to explain your work. So you can explain it that way, where you're actually talking about your comparison. That's the key. These two problems right here is pretty straightforward. This question number 3. I give you the rate law. One is second order N2O5, the other one's 0th order. Look in the appendix. So when you go to the back, here's the set of equations relating to kinetics right here. Okay. So here you can see for 0th order, this is the equation. This is the integrated rate law. This is what happens when you're trying to do a graph, and then it tells you the T1/2 as well. So use this table so you could have everything in front of you when you're doing this particular activity. You're also going to be using this table whenever you're looking up data like activation or Ka and delta H and things like that, so that we're consistent with each other. Anyway, let me go back to the original problem here. And so you know that this is second order. There is a set of equations for second order. You know this is 0th order, a set of equations for 0th order. And these questions just ask you about these reaction and the rate law, and then answer these questions. How much will the rate of each reaction be affected if the concentration of each reactant is double? Okay, so you guys can easily, hopefully, see that. If you make this 1 and now make it 2, 2 squared will change that rate by how much? This right here is very similar, for those of you in my lecture, to what we just did. Just what we just did. In this particular case, it's slightly different, I believe, because these reactions are different. But again, just connect the dots, connect the dots. This is another good practice. Okay, so that's your activity. This is basically the same question as in your lab manual. You guys have 4 experiments. They're all, I believe, at the same temperature. And this is the methods of initial rate. And you just need to figure out what is the order of A, what is the order of B, what is the order of C. And that's your answer right here, as if you were doing the activity in your lab notebook or in your lab manual. This tells you just what the calculate the average rate constant based on what these values are. Again, you guys know how to do that. If you got the rate law, then you just plug in these concentrations and this rate and calculate K. Okay, and then based on what the orders are, you guys should be able to tell me what the units of K is. For those of you in my lecture, these were questions that you saw in the last quiz. This right here just asks you, write the complete rate law. So the complete rate law would be rate is equal to K. And remember that we are at 1 temperature here. So it's not like you have multiple at 30 degrees. It's not like you have like in your lab. In your lab, you had low temperature, high temperature, and room temperature. And so you have 3 different Ks. So the rate law is still the same. The Ks are going to be different. So what you can do is you can write a generic rate law saying rate is equal to K, and then what the chemicals involved in the rate law is, and what the order is, and just say at this temperature, K's value is equal to this, at this temperature, K value is equal to that, and of course include the units. But this one, there's only one temperature. So in this question right here, you're just going to put in the rate constant will be based on your calculation. The order and the molecularity, you know, the order is just the sum of the coefficient. Molecularity is, you know, uni, bi, ter, okay? And then take a picture of that part in your lab manual and upload it here, okay? This one I talked about last time. You have 4 conditions. You've got different concentrations, and then based on the temperature and the concentrations, you should be able to tell me which is the slowest and then which is the fastest, okay? And then here, they're assuming that aluminum nitrate is 2nd order, and then which is the slowest and which is the fastest. You find out that they're pretty much the same, okay? And then upload your work here and your work should show the rationalization behind it. This one's super easy because they tell you what the rate is for the first reaction, what the rate is for the second problem. So you need to go to those equations for 2nd order kinetics and 0th order kinetics, and then just answer these questions. What happens to the rate? How fast will the reaction change based on modifications of the concentrations of these reactants? Okay, so again, it's very similar to the activity that you have, except now it's within Canvas, and it's easier for the instructors because you guys are not the only ones that are doing this. All of Chem 201 lab will have a similar type of way in which you guys put in the answer, okay? This one just talks about the half-life pertaining to those 2 reactions. And then finally, we get to the last question. And so if you solve this, then you're able to answer all these questions. What is the net reaction based on combining the 3 elementary steps? If it's not involved, put a 0, okay? Meaning that some of these are intermediate, so they don't show up in the net reaction. The net reaction is only those chemicals that they don't cancel, or catalysts. Catalysts will show up in the beginning and it will show up in the end. So just based on that, you guys just fill out this information as far as which chemical is an intermediate and which chemical is a catalyst or neither. So it's pretty straightforward in terms of choosing. And then finally, you get to this point right here where you need to put in the rate constant and then the unit of the rate constant. And the unit of the rate constant, again, depends on the rate law that you determine based on the fact that the 3rd step here is the elementary, is the rate determining step. So if you worked it out in your worksheet, okay, in your activity worksheet, then it's just a matter of transferring that information because they're practically the same, okay? And then just answering these questions. So just fill this out and then submit it. And hope